This unit is called Quadratic Equations, and in this unit we're going to be looking at solving quadratic equations, which is, there's a connection between a quadratic equation and a quadratic function, which we're going to right out of the gate talk about today, but this is less about graphs and more about algebra and equations. As I had alluded to this morning, things are going to become more and more demanding in terms of algebra. One of the ways that we can solve a quadratic equation, whatever that means, whatever it means to solve a quadratic equation, there are many ways to do it. We can solve it by using a graphical approach, which we're going to look at today and tomorrow. We can solve it by factoring, which turns into an algebraic approach. We can solve it by completing the square, which is also an algebraic approach. And we can solve it by using something called the quadratic formula, which is this cool formula that will solve any quadratic equation. But I want to point out to you that even when we talk about solving equations graphically, you have to use algebra sometimes to get the right equation. The graphical approach is just not something that's going to save the day all the time. So today what we're looking at doing is relating x-intercepts of a graph of a quadratic function. So let's pause for a second here. The language is just as important as the algebra and procedure that we're going to be using throughout this unit. When I talk about x-intercepts, I'm talking about a quadratic function. So the word function is basically, you can think of it as graph. And the other thing that's in here, and this was something that was introduced to you just a little bit in the last unit, is that an x-intercept is another way of saying a zero. So whenever we're talking about x-intercepts or zeros, we're talking about a quadratic function or a function in general. On the other hand, we can talk instead about roots of an equation. So when you talk about a function, you're referring to x-intercepts or zeros of the function. When you talk about equations, you're talking about what are called the solutions or the roots. So the word root and the word solution mean the same thing, and they have something to do with an equation. X-intercept is the same thing as zero, and it has something to do with a function. There's a lot to take in there. What we're going to be doing today is relating those x-intercepts of a function to the corresponding solutions to the equation. We're also going to be solving equations graphically, which is really what that whole first bullet is about. And then we're going to be talking about the fact that quadratic equations, and please don't get ahead of me on your graphing calculator just yet, but we're also going to be talking about the fact that quadratic equations, unlike the equations you solved last year, that are linear equations, quadratic equations sometimes don't have any solutions. A linear equation always has a solution. I can make up, this is an example of a linear equation, 3x plus 2 equals 0, and I can put any two numbers I want in here, any two numbers in the universe, and that equation will have a solution. There'll be a value of x that makes it true. In this case, the value of x would be negative 2 over 3, because to solve this, you would subtract 2 from both sides and then divide both sides by 3. So this is linear, this is last year. A linear equation will always have one solution. A quadratic equation might have one solution. It might not have any solutions, or it might have two solutions, two different numbers that make it true. And that's what distinguishes Math 10 from Math 20. Okay, to begin with, some terminology here. When you look at, and this is just an example, when you look at y equals x squared minus x minus 6, which is something you may have seen in the last unit, that's called a quadratic function. And when you looked at your exam this morning that I returned, many of you in the written response did the following. You might have written, where you were asked to come up with a revenue function, You might have written, I don't remember what the numbers are, and it doesn't matter. You might have written that. Does that look familiar for a revenue problem? But that's not a function. That's an expression. It's not a function unless you have a y. And I would have written that on your work. You need to write that. I don't believe I took off marks for it, but it's important. This thing here by itself is meaningless. It doesn't mean anything in terms of quadratics. This is a quadratic function. So something on the other hand like x squared minus x minus 6 is called a quadratic equation. The difference here is the function, they both have an equal sign. That's kind of important. They both contain an equal sign. They show some equality. But a function has that quadratic expression. This, everybody, is a quadratic expression. It's not a quadratic equation. It's not a quadratic function. That x squared minus x minus 6 is just an expression. When I set it equal to y, I get a function, but if I set it equal to 0, I get an equation. And you might think, oh boy, that's really picky. Does it make a difference? Yeah, it does. Huge difference. So to solve an equation means to find the values for the variable, it's usually x, that make the equation true. And the solutions are called roots. So if I said to you, solve, and this is not part of your notes, I'm just writing this down and asking you to think about what I'm asking or saying. If I say solve this equation, I'm saying you have to use every ability you have to find a value of x that you could put in that would make that equation true. Okay? Turns out 3 would do it. If I were to, and don't worry about how I got that, if I were to put a 3 in for x, everywhere there's an x, and I want to be able to get 0 here, 3 squared is 9, minus 3 minus 6. That in fact does give me 0 equals 0. So we would say that a solution to that equation is 3. Don't worry about how I'm finding it. There are lots of ways to find it. All right, so we're going to use our graphing calculator to determine the values of the x-intercepts of the function. And boy, I'm really highlighting the fact that it's a function. Just for today anyway, if it's a function, it's a function. If it's an equation, it's an equation. You need to know the difference. So I'm going to graph y is equal to x squared minus x minus 6. We've already got some practice with graphing functions. You should know enough to go zoom standard. We know that these things are parabolas. You can see that there are two x-intercepts. I want to talk about finding the values of those x-intercepts in a lot of detail because this is what the lesson is about today. So first of all, when I take a look at this graph, there is a huge amount of wasted space on the left and the right. Essentially, everything that is important to us is in here. I don't really care about anything outside of that. So when I go zoom standard, my calculator will automatically set up the windows to go from -10 to 10, which means I'm looking at this and thinking, well, what if I went from -5 to 6? You don't have to go -5 to 6. You could go -5 to 5. You could go -4 to 8. My point is I'm going to kind of, I'm going to lop off those two ends. I don't need them. So zoom standard kind of takes me to a place where I can make a decision. And now my decision is let's go from -5 to 6. And hit graph again. So now we want to find the x-intercepts. Now I'm going to remind you of something. X-intercepts are called zeros. X-intercepts are called zeros. When I go to my calculator calculate menu for graphing, if I want to find the x-intercepts of that, then I go to my calculate menu and I choose 0. That's what I'm finding. That's an x-intercept. It's called a 0. So I hit enter. I put my cursor to the left of one of the x-intercepts. I think many of you can just look at the graph and tell me what they are. But it's not always going to be whole numbers or integers. There could be decimals involved. So I put my cursor to the left of this. I hit enter. I put my cursor to the right. I hit enter. I hit enter. It's -2. I do the same thing on the other x-intercept. I go back to my calculate menu and choose option 2, which is finding a 0. I put my cursor to the left of it. You might be wondering here, how close do you have to be? I think you just have to be on the left of it. I don't think it really matters. I think the closer you are, the quicker your calculator can find it. So that's good. Right boundary, hit enter after you get to the right of it. And again, you don't have to scroll. You could just type in a value of x for the left or the right. And then guess. Well, we don't need to guess, but the other one is 3. You can see by looking at what's on the screen why it's called a 0, because it's what makes y 0. So the two x-intercepts are 3 and -2. We can write that in. And I would like you to get in the habit of putting x-intercepts as an ordered pair. We don't always have to. If you just put -3 and 2, that would be fine, but it's -3, 0 and 2, 0. So far in this warm-up, there's nothing that you didn't know how to do already, other than the fact that you got a teacher standing up here harping on the importance of terminology. That's all. All right, what's the second part of the warm-up say? It says substitute the value of the x-intercepts into the quadratic equation. So we've switched gears. In the first part of the warm-up, we were dealing with a function. You can see it's a function because of this y equals. Now in the second part of the warm-up, you can see that we're dealing with the equation, and you can see that it's an equation because it has that thing equal to 0 and not y. What's it saying to do? Take this x-intercept of -2 that we found and put it into that equation. So we're going to put -2 squared in brackets minus -2 minus 6, and then this is supposed to be equal to 0. I hope everybody appreciates that not every value of x will make it equal to 0. Right? So really at this point in time, we don't know if this is going to work or not. It will. That's going to be the point. So I figure out what this is in steps. -2 quantity squared is +4. Subtract the -2 means to add +2, and then we have -6. So we end up with 4 plus 2, which is 6 minus 6. We get 0, which is equal to 0. Jackpot. This x-intercept of the function is a solution to the equation. Let's see if that works for the other x-intercept. We would have 3 squared minus 3 minus 6. This is, well, we're trying to find out if it will be equal to 0. So 3 squared is 9 minus 3 minus 6. -3 minus 6 is 9, so you get 9 minus 9, which is 0, which is equal to 0. Jackpot a second time. So what we have learned, I want to go back to the beginning, which is actually at the top of your page, is the highlighted part says, today we have to learn how to relate the x-intercepts of a quadratic function, like like y equals x squared minus x minus 6 to the solutions of the corresponding quadratic equation. Well, the corresponding quadratic equation is the same quadratic expression equal to 0. So what's the relationship between the x-intercepts of this function and the solutions of this equation? They're the same. Okay. So we are asked here to write, what do you notice? Well, what do we notice? Let's see. We notice that the x-intercepts of y equals f of x are the solutions to f of x equals 0. F of x is just the expression. If I graph y equals the expression and find the x-intercepts, I will be solving the equation that's the expression equal to 0. Why is this? Like, why should that be the case? Well, if I asked you to solve, just imagine. I said solve x squared minus 2x minus 8 equals 0. And then I said find the x-intercepts of x squared minus 2x minus 8 equals y. So I have these two problems. What do you always do to find x-intercepts? You change y to 0. If I say find the x-intercepts, you're going to go, oh, x-intercepts are where y equals 0. So you're going to take this equation, you're going to rewrite it, and it becomes that, which is the equation that you're solving. It's just that what we're doing is solving that equation in a non-algebraic way. We're looking at the graph. So to turn it around the other way, if I say to you, solve this, then you can say, you know what? I know there's no y there. Why don't I make it a y and just find the x-intercepts? Because my calculator can find the x-intercepts. Even though there's no y, I'm going to imagine there's a y. So I hope that helps in your understanding here. I don't particularly care what you have written down for an explanation. When I say explanation here, I'm explaining to you. So solve each by graphing. Okay. Is there a y here? No. So this is not a function. How do we graph something that's not a function? Well, you know how you do it? You change it into a function. We're going to change it into a function. And we're going to find the y-intercepts. Sorry, I misspoke. We're going to find the x-intercepts. And we say to ourselves, well, how do we find x-intercepts? We change y equals whatever it's equal to. We change it to 0. But then we'd just be running around in circles. So we use our graphing calculator to find the x-intercepts. That's all. Since the x-intercepts of that function are the solutions to the corresponding equation, all we do is graph y equals 3x squared minus 10x plus 8. And that's the way I enter x squared. Sometimes I do it without even thinking. It doesn't matter how you enter it as long as it's correct. We did go to a different window setting last time, so I would recommend going back to Zoom Standard, which is Zoom 6. Ooh. Is that what you're looking at as well? Pretty tiny little thing there. I think we want to bring that into view, and I don't know if I have used this feature of your calculator with you yet. Have we ever gone zoom box? No? It's beautiful. It's a thing of beauty. I'm going to go zoom box, and there will be a little blinky cursor right in the center at the origin there. And I can scroll around, and I'm going to dump that about here. You have to play around with it a bit, and I'm going to hit enter. And that's going to nail down that point there. And now I'm going to continue to scroll. And it's like a piece of elastic that I can stretch out into a rectangular shape. And when I hit enter the next time, my calculator is going to look at that little rectangle and zoom that to the full screen. So I'm telling it, change the window settings so that I'll be looking at that. As I hit enter again, that's much better and much easier to work with. Let's all find the x-intercept on the right-hand side first. So we choose 0. Put our cursor to the left. Put our cursor to the right. Hit enter, 2. So we have one x-intercept. And I'm just going to put equals 2 here. I could put 2 comma 0. I'll tell you why you have to be careful with how you write these in a second. Now I'm going to do the same thing on the other side. So go to my calculate menu, choose option 2, which is finding a 0. By the way, you can hold your key down. I can't, because if I hold it down for any length of time, it thinks I want to right click. So I have to keep doing it this way. I hit enter, then I scroll to the right. I hit enter, and then I hit enter. Now, my goal here today is not to teach you fractions and all that stuff, but we want exact values, and that x-intercept is 1.3333. So you can either know that 1.33 is 4/3, which it is, or, this is interesting, when you take a look at your calculator right now, before you've done anything else, it says x equals 1.33. Right? When I go to my home screen by going second mode or quit, I'm going to actually capture this so that you can see it if you're watching this in a video. I gotta wait. There it is. There is a key that says X. And what I can do now from the home screen is pull up that X, there it is, and go math, enter, enter to convert it to a fraction of 4/3. So anytime you calculate an X value in the graphing screen, it stores it temporarily inside of that X key, which is nice because then we can easily convert it to a fraction. So what does this mean? It means that the two x-intercepts are 2 and -4. So the solutions are x equals 2 and x, I don't know why I said -4. 2 and 4/3. So x equals 2 and 4/3. I would be very hesitant in putting a comma down here where we have x-intercepts, because you might think that's an xy ordered pair. That's it. Questions with number 1? All right, number 2. Oh, no. Not only is there no y, there's no x. And I hope that gets a smirk out of most of you, because clearly we can just pretend p is x, right? So whatever the solutions to this equation are, they will be the solutions to this equation And whatever the solutions to this equation are will be the x-intercepts of this function. I mean, you just have to be adaptable. Whoops. I kind of have a function equation all together there. I don't want that. I just want that. So I'm going to find the x-intercepts of that function. They will be the solutions to the equation. This is the first time in this whole course where really there's no work required at all in terms of writing stuff down. That will change. But so what do we have? Y equals 8x squared plus 18x minus 5. Bless you. Zoom standard. Always go back to zoom standard. Again, I'm hoping that every time I talk about window settings, you get better and better at this. We know something about quadratic functions, that this quadratic function, y equals 8x squared plus 18x minus 5, opens up. And looking at this graph, we can see that there is a part of the graph here going down. There's a part of the graph here going down. The vertex must be down below somewhere. It would be nice to pull the vertex into view, and it would be nice to clip the wings of this screen to get rid of all of this. I don't need any of that, and I don't need any of this. So I'm thinking of going from -4 to 2. That's my idea. And I'm thinking instead of going from -10, which is what the window setting does for y, min, I'll go down to -20. So window -4 to 2, and let's go from -20 up to 10. I hope these things I'm showing you every time we have to talk about the window settings are helping, because I know that that can be frustrating to get the right window settings. It really can. I'd take a minute and find the x-intercepts. Again, everybody, I prefer, as long as you know what, let me back up. When I set up my window settings for x, I went -4 to 2, and I put the scale at 1, which means I know looking at this that this is negative. Why does it keep doing that? That this is -4, this is -3, this is -2, this is -1. So when I found that first x-intercept, and I went to my calculator and chose 0, I just looked at the graph and saw that it was between -3 and -2. I didn't have to scroll, so I entered -3, enter, -2, enter, enter. I can do the same thing with the other one. I can see it's between 0 and 1, so calculate the 0. Left would be at 0, right would be at 1, and it's 0.25. You convert both of those to fractions, and you get x, this is the solutions to the equation, x equals 1/4, and x equals -5/2. Are we okay with that one? Yeah.
Is it necessary to put it as a fraction when it's just something really simple like
No, it's not. You're absolutely right. If it's, I've always called these nice decimals. Like -2.5 is nice. It's not -2.563821117. It's not necessary to put them as fractions in this case. They might be written as fractions, though, Thomas, on an exam for multiple choice. All right. So this, I just throw a little wrinkle your way. You always need to zero quadratic equations. This is a quadratic equation that we're looking at. And in order for you to solve any quadratic equation, you have to zero it. What does that mean? It means you have to make sure that it's equal to 0. So all we're going to do here is subtract 2 from both sides and get 9x squared plus 7x minus 2 equals 0. Is it really necessary here in your notes right now for you to write y equals 9x squared plus 7x plus 2? No. Hopefully you've learned that what we're doing is finding the x-intercepts of the corresponding function. So let's do that. I'm going to give you a minute to put the graph together in your calculator with appropriate window settings and to calculate, using the calculate menu, the zeros of the function or the equation. I'm going to do it here. If you're feeling a little lack of confidence here, you can follow along, but hopefully you should be able to do it on your own. By the way, when I went Zoom Standard, my brain said this is an ideal situation for using Zoom Box. The only disadvantage to using Zoom Box is you haven't picked the window setting, so you don't know what the ticks are at. You kind of do. -1. And 0.2 repeating. So the solutions to the equation, the roots to the equation are -1 and 2/9. How are we getting 2/9? You're just going to your home screen after you get that one. You're hitting math, enter, enter. Or you know that 0.2 repeating is 2/9. Still good? All right. So we will zero this equation, which will give us 4x squared minus 20x minus 25 equals plus 25 equals 0. My mistake. This one has a little wrinkle in it, tiny wrinkle. I'm not going to bother writing y equals this time. After hitting Zoom Standard, I'm going to make the decision to go to my window settings and go look at the graph again. Go from 1 to 4 for x. There's a lot of wasted space there that I don't need. Looking at the graph now. I'm at a loss. Well, I'm not. I know what's going on here. But is it possible that that graph goes below the x-axis? Possible. Maybe it does. You just can't see it. I'll save you a heartache here. If you try to zoom in, the more and more you zoom in, the more and more you discover it doesn't go below the x-axis. There is a way algebraically to know it doesn't, but we're so far away from that right now. Let's just find the x-intercept. We'll go to our calculate menu, choose option 2, go to the left of where we think the x-intercept is and hit enter. Go to the right of where we think the x-intercept is and hit enter. And it says 2.5. Now my calculator says 0.000011. Does anybody else have a calculator that says not exactly 2.5? Does it have 0.000011? Yeah, some of them will be 2. It depends on where you chose your left and right boundaries, but we have to use common sense here until we know the algebra. It's 2.5. Okay? And there is only one solution here. X is equal to 2.5. And on to number 2. Now we're going to do this to 2 decimal places. One of the things you will notice is that in every equation we were solving in number 1, they worked out to nice decimals. 2.5, 0.2 repeating. These ones are not. So I'm going to go through these pretty quickly. And I don't know why my calculator is doing that. Export. Oh, well, I'll fix it later. So I can see some of you, by the way, have already gone through many of these, but let me go through this with you. Zoom standard. I can see 2 xintercepts. I'm going to show you how you don't have to necessarily make it a nicer looking graph. Can everybody see that that first xintercept is pretty close to -1? So when I go to my calculate menu and choose 0, why don't I just put for the left boundary -2 and for the right boundary 0? I mean, why bother scrolling around? So it's about -0.78. You can see looking at the right intercept that it is 1, 2, 3, 4, 5, it's somewhere I think between 6 and 7. My mistake, I believe it's someplace between 5 and 6. So if I go to my menu, and you don't even have to be close. I can go left boundary 3, right boundary 8. I just have to be to the left and the right. So there is the other one. I'm not going to bother rounding them. That is not the point of this lesson. Are we okay with this? Okay, I can see that some of you are getting bored. Let's try this one. You go ahead and solve this equation graphically for me. That's what it means to solve it graphically. You're going to graph the corresponding function and find the x-intercepts. So here is an issue. I'm sure that many of you are at this point already. You've gone Zoom standard and you can't see anything, right? It'd be frustrating. I'm pointing out the downside to solving graphically, because if you solve this algebraically, you can tell right away there are no solutions. This parabola opens up and it is further up on the screen than you can see. If you go to your window setting and look up to a higher value of y, like 20, and why do I even know I want to look up there? Because the y-intercept is 12. It's got to cross the y-axis at 12. I'm still using my knowledge from the previous unit. So when I look at this, there's the parabola. It opens up and it's above the x-axis. It has a positive a and a positive q. There's no x-intercepts. There's no solutions. No roots to that equation. I think you get the idea. We can bypass this one and this one. We have encountered quadratic equations that have one solution. We've encountered quadratic equations that have two solutions. You've encountered quadratic equations that have one solution. So, what are the three different situations that can arise? Well, let's just answer this pictorially. If the corresponding quadratic function has no x-intercepts, then the equation has no solutions. If the corresponding quadratic function just touches the x-axis in one place because there's one x-intercept, then there is one solution. These two, well, the parabola on the left isn't rare. Lots of parabolas might look like that, or they might open down and be below the x-axis. The ones that just touch the x-axis are very rare. But the most common one, of course, would be, well, I don't know, most common. We see very frequently parabolas that have two x-intercepts, and this would mean two solutions. And we have one more example we're going to do. You can run from word problems, but they will always catch up to you. Okay? So we have a word problem where we have two numbers that have a sum of 46 and a product of 396.75. We want to determine the numbers. We've got to find two numbers that add together to give 46, but they have a product of that other number. This looks kind of like a setup for a max-min problem, but it's not. We are not going to have a y here. We're going to have an equation to solve that has x. So the first thing we're going to do is we're going to set x equal to one of the two numbers. Now, what's the other number? We don't want to introduce another variable because what we want is the following. We want to, out of this, get an equation that looks like this so we can find the x-intercepts of the corresponding function to answer the question. We only want one variable. It's got to be x. So what will be equal to the other number? What can we write for an expression for the other number if the first number is x? Sasha? Sure, 46 minus x. I mean, just think about it. Let's say one of the numbers is 6. What's the other number? Well, it has to add to give 46. The other number must be 40, which would be 46 minus the first number. So this is 46 minus the first number. Those are the two numbers. Now, they have to have a product of 396.75. Okay. That means that x times 46 minus x has to equal 396.75. Now, is what I've just written here, is this an equation? Sure. It only contains one variable, x, so it's possible to solve it. But what you need to do is simplify this first. So when I simplify this, and by the way, I'll slow down here. You always simplify before you start to solve something. That's the point of the word simplify. I've mentioned this before. You know, if you want to get 12 donuts, you don't walk into Tim Hortons and say, get me root 100 plus 8 over 4 donuts. You don't say that. You say 12 because 12 is simpler. By the way, I hope the square root of 100 plus 8 over 4 is 12. It is, okay. I mean, you want to simplify things first, always. Or, you know, you could go in and do that and then just get a blank stare. That's up to you. How do I simplify x times 46 minus x? Well, I distribute that x through. And I get 46x minus x squared equals 396.75. And now I have to talk about something that I haven't talked about. You look at this and you see the x squared and you go, oh, it's quadratic. This is not a linear equation, it's quadratic. And that means you have to zero the equation. Always zero a quadratic equation. This is the new thing. Since the x squared is negative, I would always arrange my equations in zeroed form so that x squared is positive. So rather than subtracting 396.75 from both sides to make it equal to 0, I'm going to add the x squared to both sides, subtract the 46x from both sides, and leave the 396.75 where it is, so that's equal to 0. So I've moved this term across the equal sign, and I've moved that term across the equal sign. One little bit of business now. We'll get to the solution in a second, because it is tricky. Even though I moved stuff to the right, if I were doing this, you will find very often I will do the following. I moved everything to the right, but I'm still going to write it on the left. Because if it's 0 equals that thing, then that thing is equal to 0. Okay, so now we have to find the x-intercepts of this. And even once you find the x-intercepts, there is a subtlety to this question that is very, very slippery, mentally slippery. So I'm going to enter x squared minus 46x plus 396.75. One of the things I want to recognize here is that x is going to be a positive number. These two numbers are going to be positive. And I don't know if it says in the question, does it say two positive numbers? It doesn't. I would normally put it. Now, they could be negative later on. It might get more complicated. I'm going to leave this out for the time being. Maybe I don't want to discuss that. So let's graph this now. I go zoom standard. I hope it's no surprise that you're not going to see anything. And the reason you're not going to see anything is because the y-intercept is in the hundreds, right? So what can we do here? I suppose what we could do is set up our table to start at 0 and go up by 1 automatically. And this is not necessarily a quick thing, but it's a sure thing. And now I can go to my table and I can scroll around. Well, it's going up, it's going up, it's going up. If I scroll in the positive direction, what's happening here? It's going down, down, down. If I'm really patient, I can just keep going. There we go. It's crossing the x-axis somewhere between 11 and 12. I mean, you really might have to think about this. But when x is 11, the y-coordinate is above the x-axis. When x is 12, it's below. So the first x-intercept is somewhere around 11 point something. That tells me that in my window settings, I want to look in that area. I want to go up to at least that point. And since we know from the behavior of the chart or the table that y is decreasing to that point at about 11, it's got to stop someplace and go back up. Now, if you're really up for it, you can complete the square and find the vertex and set up the window settings that way. But I think if we go from 0 to, let's see, if it's coming down at 11, maybe it'll go up. Well, it's going to go up past 11, but remember something. The two numbers have to add to give 46. I might just go 0 to 46. That will include any of the numbers that would be between 0 and 46. Let's just try graph and see what happens. Now, this is really good. Doesn't really look like a parabola, does it? Do you understand the difficulty in trying to put your cursor in finding this x-intercept? Do you understand the difficulty in trying to put your cursor to the left and then to the right of that point? That curve is so steep. So how do we take these two sides of the parabola that are so steep and bend them out? The answer is we have to increase our y window setting to bring the vertex back up into view. Now, I don't know. Right now it's going down to -10. I'm thinking let's go down to -100. Then if it's too much, it's too much. We can back off later. So now I can go to my window setting. Let's try -100. And as soon as I said that, I saw a couple people shake their heads. Oh, even further, eh? The only problem is now I have to be able to put my cursor to the left and the right of these. And I'm running out of space up here. So if I go down to -150, I guess I'd better bring the top down as well and maybe go up to 50 or 75. This is a tricky question to solve graphically. So, well, let's just try this. Let's just try going 75 for y max and see what that does to the graph. Oh, that's better. This is the part where you're going to experience some frustration. So let's find those two x-intercepts, and then I'll talk about the answer to the question. Calculate 0. Enter. That's the left. Go to the right. Enter. Enter. So one of the x-intercepts is 11.5. And when we find the other x-intercept, the other x-intercept is 34.5. Now, by the way, I don't want to spend class time on this right now. This is 0. It's an exponential notation number, and it's very small. But listen to this next part very carefully. There are two solutions to that equation. Don't forget, x was the first number. There's two solutions. The first number could be 11.5, or the first number could be 34.5. Okay? What I'm pointing out, and this is really complicated, is that these two x-intercepts are not the two numbers necessarily. They're not the two numbers we're finding. They're the two different sets of answers you can get. Turns out they will be the same as the answers. But if x is 11.5, then 46 minus x would be the other number, which would be 46 minus 11.5, which gives, I need some help there, 34.5? 34.5. If x is 34.5, then the other number will be 46 minus 34.5, which will be 11.5. And what I'm telling you is, I know you might think, oh, you're just being picky, but I'm not. I'm telling you this is a pair of numbers that's an answer to the question, or this is a pair of numbers that's an answer to the question. They happen to be the same pairs of numbers, right? But you are going to see problems where this pair of numbers will not be the same as that pair of numbers. These are two different solutions that happen to be the same. And I know that's a difficult thing to wrap your head around. Anyway, the two numbers are that. Let's just check it out. Do those two numbers add up to give 46? Yep. When you multiply them together, do you get that 396.75? Yeah. So this lesson is about solving quadratic equations graphically and about starting to build quadratic equations from word problems. And I'll tell you right now, if you knew how to solve this quadratic equation here algebraically, you would much rather do it algebraically than graphically. Okay. So we have some problems to work on for practice. Tomorrow we will continue doing this a little bit more, and then when we get back from spring break, yes, spring break, we're going to start looking at algebraic methods of doing this kind of stuff. We might even get started on it tomorrow. I'll have to look. Anyway, clear your heads, get to work on this, and I'll come around. I'll give you a hand when I get a minute.